Hello, everyone. This is Francesca Vigliani from Cloud Academy. Thank you for joining us for episode number 4 of our Pandas Like a Boss webinar series. It's very exciting to see so many of you connected for this session. Welcome back to those of you who already participated to the previous episodes. If you missed out, you can find the recordings on the Cloud Academy website in the webinar section. And before introducing our speaker, just a few housekeeping announcements. I'd like to remind you that this webinar is being recorded and will be shared with you via email. During the webinar, we will leave time for your questions, so feel free to add them in the chat box and our expert will try to answer them during the final Q&A. Lastly, we hope you had time to set up the environment so that we can get going with the session, but if you had problems, don't worry. You just need to have the data on your Google Drive, and Andrea will show you how to read the data from that source. This session will be slightly different, but I will let Andrea tell you all about it. It's going to be very exciting. And I guess that's it for all the announcements. So without further ado, let me introduce you to our data scientist, Andrea Giusani.
Thank you, Francesca, and welcome everybody. Firstly, again, it's so exciting to see so many people even today, and therefore thank you for participating. At first, just a brief introduction of myself for those who don't know me. I'm a data scientist here at Cloud Academy, where I mainly focus on the development of machine learning algorithms to provide state-of-the-art solutions to improve the quality of our product. You can reach me out on LinkedIn, or you can visit my website for updates on machine learning or Python in general. All the details can be found in the webinar-specific GitHub repository, and the URL is provided in the registration email. Just to be clear, I will upload the final transcript of this webinar as soon as we finish the live session. So the agenda goes as follows. We're going to recap a little bit what we did 3 weeks ago in the last webinar. And then we are going to understand the today topics. And finally, we are going to speak about the environment and the data before get our hands dirty. Okay, so this is the 4th episode of our Panda series. I hope you have enjoyed so far. And in particular, last time we have understood how to transform a data frame using different techniques. If you don't remember those, I'm just gonna provide a little recap here. We saw the pivot method, which is useful to transform a data set into a more readable data source, and the unstack method, which is somehow similar to the pivot, but it's pretty useful, especially when you are dealing with multi-index data frame. And on the other hand, we have seen and investigated aggregating techniques related to Pandas. In particular, we saw the pivot table and the group by. At the end, the two functions provide the same output, but it's interesting to highlight the fact that the pivot table it's a pretty efficient function that allows you to basically provide an aggregated statistics to some columns. The group by instead is, I would say, is as efficient as the pivot table, but it's more dynamic and flexible with respect to the pivot table. Having said that, if you have missed that and you want to get more on those techniques, the webinar, don't worry, because the webinar is publicly available on the Cloud Academy YouTube channel. And I believe the link is provided as well in the registration email. So check it out. Today's webinar is a little bit different, I would say, compared to the previous one, because today we are not gonna focus specifically on a set of functions, and we are not gonna understand the logic behind those functions, but I would say we are going to focus on a type of data, on a particular type of data, which is the time series data. And the interesting fact is that we are gonna look at 4 different functions that typically are employed within the Pandas framework to deal with time series. In particular, we're going to understand the diff function, which basically is used to get the difference between successive rows in a data frame, the PCT change, which actually compute the percentage change between rows, the shift, which actually compute the difference, again, between rows, or I would say it's not the difference, but is actually extracting from rows, from a particular row, the value with respect to a specific period that we are gonna specify inside that particular function. And finally, the rolling, which is a function that is pretty useful to compute actually aggregating statistics in a time window period. As I said, today we are going to focus on a class of data, which is the time series one. And in particular, we would like to actually get more insights from our data and try to build a business solution with our Pandas knowledge on a real case scenario. And I will provide, obviously, more details in a few seconds. As usual, I want to speak with you before starting our live session about the environment and the data. As usual, we're going to use the Google Colab environment to perform each single live session. I have written a README, which is available on our webinar-specific GitHub repository. And that README tells you how to set up a Google Colab notebook if you're not familiar with it. I assume you have read and set up the environment already, since all instructions were provided before the start. As for the data, we're going to use two data frames that contains the time series of Amazon and Tesla stock, respectively. You should be very familiar with those two data sets at this stage of this Pandas series, since we have used those data set in episode 2 and 3. In particular, we're gonna take into account the closing and the volume series of the corresponding stocks, namely Amazon and Tesla. So without further delay, let's jump into our collab session. You should have something similar as the one you see here on my screen. And as usual, what we have to do is actually to set up the environment. In particular, we have to tell the Google Colab to read the data from our drive. And to do so, we actually use the usual commands that is available on GitHub. And it was provided, all the instructions were provided in the email registration email. But anyway, let's write together that one. So from google.colab, we import drive. And then we mount our drive so that the Colab environment is able to read the data from our drive. And the syntax goes as follows. So once you have typed those two lines of code in your Colab session, you just need to run it, and an authentication process is required. And in this case, you are actually allowed. You have to basically allow Google to access to your drive, basically. And to do so, we are gonna authenticate. I'm going to authenticate with my email and then copy and paste in this text box. Just a few seconds and then we will be ready. Here we go. So this message means that our drive is mounted in our Colab session. And in order to check that, you see here on this left panel that now the drive appears and you should find all your data. inside here. Okay, so what we have to do actually is as follows. We have to first import the data, transform a little bit those two data frames in order us to perform some data analysis with respect to the time series data. So let's start with the usual import. We import pandas SPD, classical import. We need pandas, right? So let's import it. And then we import and we assign to the Amazon df variable the data related to the Amazon stock. And to do so, you should be, again, very familiar with that. We use the pandas read CSV function. And what you have to do is actually go into your drive, remember where you store the data. In my case, is in this folder. I'm gonna get the data. I'm gonna copy the path, and then I'm gonna paste the full path inside the read CSV method. And if you remember from last time, this data has an extra column that is actually an index column. So we are gonna set the index. We're gonna set the index call is equal to 0. And last time I also told you that since we are dealing with actually a column named date, which contains actually the trading date for which we observe some values, it's better to parse that date as a date, as a date time. So to do so, read CSV is a powerful function since you can actually pass to the parse dates argument the column you wish to parse as a date time, in our case, the date. And again, I like telling you some tips and tricks every time we have the occasion to interact with each other. And today's tip is about the possibility to deal with different variable types inside the read CSV method. What does it mean? It means the following. So let me run this cell, and if you try to let me say access to the first 5 rows of this data frame, you see that actually we have a date, a closing price, volume, and a symbol. So our data set is pretty easy, right? We don't have strange D types or whatever. But suppose that for your personal goals and the job, you are required to parse a specific column with a particular D type. For example, take the volume. The volume in this case is obviously an integer, right? So suppose that you are uncertain about the fact that the volume is either an integer or a float. And suppose that you would like that column to be an integer. You can force that column to be an integer by using the dtype argument inside the read CSV, which is pretty cool since it just requires you to specify a dictionary, a Python dictionary, obviously, which requires the column name as first, in our case, the volume, and as value, the type you wish to apply to that particular column. In our case, we want that column to be an integer 64. Okay, just an integer is fine. And here, with this simple instruction, we are sure that when we read this data, the data we are importing is actually of type 64 with respect to this column, volume. So I'm gonna do this and do the same for the Tesla DF, Tesla data frame, and obviously be sure that now you read not the Amazon, but the Tesla CSV, and the same is unchanged for the Tesla DF, namely the index call, the parse dates, and the D type. Okay, so far so good. Again, today we have learned another extra tip for this function. So now let's move to the meat of today's webinar, which is the time series data. So if you remember, last time we actually concatenated the two data frames in order to have a unique data source from which we are going to read the data. Again, let's do this again because it's pretty important for us to remember what we did so far, but in particular, we need to be prepared for our data analysis. So we're going to concat the Amazon DF and the Tesla DF using the concat function. And in particular, if you remember, we need to sort the values with respect to the date. And so we are going to pass the date and also the symbol, since we want that list to be sorted not just with respect to the date, but also alphabetically with respect to the stock we are considering. And then remember that sort values requires a by argument, but also the ascending argument. And in particular, we are going to set this as false for the date, but true for the symbol, meaning that we're going to read the data from the lowest to the maximum, from the minimum to the maximum date, and from the A to Z with respect to the symbol, alphabetically, obviously. It's an alphabetical order. And then we reset the index just to be sure that we are not messing up the index for the new data frame. And here is everything that you must write in order for this data frame to contain all the information related to the Amazon and Tesla data frame. Just a simple expression for you. And here we go. We have a date that starts from January 29th, 2021. Okay, so it's here we are starting from the maximum to the lowest, sorry. And then you have an Amazon, which is actually in alphabetical order, and therefore the ascending is true. Okay, so once we have the data, we can actually aggregate them using the pivot that we saw last time. And we basically compute a pivot table for the closing price by applying to the df underscore all the pivot table, or let me say the pivot, it's better because we don't need to aggregate at this stage. And the pivot close requires three arguments, if you remember: the index, which is nothing more than the column from the original data frame we wish to have as index of the new data frame, in our case, date. Then we have the columns, which is the columns or the column or the set of columns from the original data frame we wish to have as column of our new data frame, and we want those columns to be the values, the distinct values of the symbol column. And finally, we have the values. And as I said, as the name suggests for this variable, we're going to take into account the close column from the original data frame. And just to be sure, we also sort the index and we make this sorting in ascending order. Simple inspection, you get that we have basically a column date, which is our index as expected, a column symbol, which is made of different values for our symbol inside the symbol column, and the values. So this is the starting point of our analysis. And therefore, today I want to basically focus on two main objectives. At first, I want to understand with you the methods or the techniques that are available in Pandas to evaluate the performance in stock. So, for instance, we have different methodologies. We can, at first, compute the difference in absolute terms with respect to stocks price. Therefore, we're going to take, for instance, the column Amazon, and we're going to compute the difference in price for each single pair of dates. So this is quite a pretty easy solution, but let's try to see how it works in Pandas. So let me call this how to evaluate the performance in stocks. And therefore, I'm gonna suggest as first a difference in price. And to do so in Pandas, it's pretty easy, since there is a method called diff that is applied to our pivot close dataset. And the diff is gonna apply for each single row, is gonna take the difference with the previous row, and is gonna create a new column for the data frame, reporting the difference, the absolute difference between two successive rows. And in particular, you can specify this requirement, namely that you want to take into account two successive rows by specifying periods equal to 1. If you try to print these first 5 rows, you see that you have created a new data frame where obviously the first one it's empty, since you are not able to compare this row with the previous one. It's impossible. But then you get some values. You get the difference in price between this time series data value with the successive one, and the difference is 11.6, and so far, so on and so forth. You can go on, and automatically Pandas is computing for you the difference in price. The nice thing about this function is that, so let me first apply this. Let me store this into the variable simple diff data frame, just to keep track of that. But the nice thing about this this function is that you can compute the difference between the next. Let me say like this: you can compute the difference with respect to each single successive rows, namely by specifying -1 in periods. So before you were computing the difference with the previous row, if you remember. So 11 was computed by taking into account the first and the second row. When you specify -1 instead, you are going to take into account the first row, and that first row will be evaluated with respect to the successive row, namely the second one. And indeed, if you pay attention now to the result, you get that the 2027 one, first row, has actually a value which is -11.6, which is nothing more than the positive difference that we got with periods equal to 1, since before we were computing with respect to the previous row, now we are computing with respect to the successive row. And that is made by specifying periods equal to -1. So this is a first case. Obviously, you can compute this diff with respect to any periods you like. I just leave this for your curiosity, but you can actually be very, very flexible and compute any difference you like. A thing that I would like to highlight now is this one. So I'm gonna plot actually using the plot function from Pandas. The two series that you see here, namely Amazon and Tesla. And the nice thing about Pandas is that it has implicitly a backend solution based on Matplotlib to visualize your data, which is pretty useful, especially when you are developing some solutions. And therefore, it's pretty direct, because with Matplotlib you should write a few lines of codes to get this output. But with Pandas, you just need to call the plot method, which is a wrapper of Matplotlib, based on Matplotlib, and then everything will be shown in just a few seconds, as you see here. So the plot is nice since it allows you to get an idea of what's going on your data. If you pay attention, remember, we are taking into account the difference in price between data in a time series, okay? We use the diff, which actually compute the difference in absolute magnitude between data. And if you pay attention, we are taking into account an Amazon and an Amazon series, which seems to be more volatile with respect to Tesla. Obviously, this is a wrong assumption, because they look, I mean, the blue one looks more volatile with respect to the orange one, because they actually have different magnitude. If you remember, look at here, Amazon is expressed in 1,000, Tesla in hundreds. So this is quite a wrong assumption by saying that Amazon is more volatile with respect to Tesla in comparison to the returns. So in order to avoid this conclusion, typically people tend to use simple returns to evaluate the performance in stock. If you don't know anything about simple daily returns, don't worry, because actually it's a financial definition, but it's pretty simple definition. It's an algebraic equality that I'm gonna tell you now in a few seconds. So daily returns, it's a second possibility to evaluate stock performance. And as I said, those are defined as basically the ratio between the price you observe at time t, the actual time, with respect to the price you observe at the previous time, t minus 1, minus 1. So it's actually like this, p underscore t over p underscore t minus 1 minus 1. Okay, it's pretty easy. So this is actually the simple returns at time t. So basically, we want to apply this simple function, mathematical equality, which is not a function, but it's actually an equality, in order to compute simple returns. And luckily, life is easy with Pandas, since there exists a method called PCT change, which allows you to compute directly this expression in just one line of code. And in order to do that, I'm going to create a custom method called daily returns. Let me say like this, that requires basically an argument, which is the row. And for each single row, we're going to apply the PCT change function that I just mentioned. And once we have defined this custom method, by the way, it's not necessary, but it's useful for us because we are going to apply that function for each single row. Once you have defined that, we are actually going to take into account the pivot close method, and we apply the method that we just created by using, obviously, an anonymous function, a lambda function. And we apply the daily return for each single row on the pivot close function, on the pivot close data frame. And we store this into the simple returns data frame. So in just one line of code, we have computed the simple returns, and the result is as follows. You get, not surprisingly, the first row is none, since you don't have anything to compare with for the first observation. And then you get observations that, if you pay attention, are expressed in percentage. And this is quite interesting, right? Since if you think about, we have cleaned our original data from magnitude, which might cause some distortion in our data analysis. And in particular here, you see that now, since the data are expressed in the same magnitude, you can compare easily the two stocks and understand which is the one that gave you the highest profit. And to do so, you can actually apply again the plot function as we did before. So we are going to take the simple returns df, and we apply the plot function, and we apply the fixed size argument. It's not necessary just for visualizing the output in a better way, especially from you, but it's not necessary if you are performing this on your local laptop. So here is the result. If you pay attention, remember before we had such kind of behavior. It looked Amazon was pretty erratic. By cleaning actually this time series with some by cleaning the series from the magnitude, you can easily see now that instead Amazon is more stable with respect to Tesla. Tesla is much more erratic with respect to simple returns, whereas it's much more stable Amazon compared to Tesla in terms of returns, daily returns, obviously. So this is pretty interesting. The same result can be obtained, by applying another function that comes from the Pandas library called shift. This function instead requires a little bit of, let me say, writing from your side, because you have to basically write by yourself with Pythonic language. You have to write this equality. So basically, you need to take the pivot close in position, for instance, Amazon. You have to divide the same column, but by taking into account the next row. So basically, we're going to take the periods equal to 1. And then you take -1. Sorry, it's not the success, is the preceding row, because shift is going to take into account not the successive, but the previous rows. Sorry for that. So in this way, you are going to take into account the price at time t, the price for Amazon at time t -1, and you specify t -1 using the shift method. And then you obviously take -1, since this is necessary for our equality. And if you take into account this and you actually print the result, you see the first meaningful result is 4%. The second is 0.4%. Here you have a 5.7%, which is actually the same result that you obtain with the PCT change. So it's up to you actually at the end of the day to choose which function you can choose the function you like. I like, for instance, the PCT change. I find it much more direct and easy to apply, but obviously you can apply the shift on each single stock and get a Pandas series as the one you see here. It's up to you. Okay. So typically, you have simple returns. You can apply also log returns. It's not the aim of this webinar, but you can find a few material in our Cloud Academy content library that actually investigate log returns applied in to financial use case as this one. So if you are interested, you can check the content library in our in the Cloud Academy website, and you will find some interesting material on that particular case. What I want to focus instead is on a particular function that is pretty useful to build a trading strategy. So let me call this section in this way. It's pretty a clear name, but you know, at the end of the day, as an investor, or actually as a simple user, you would like to understand whether you are getting profit from your trading strategies or not. And if not, you would like to build a trading strategy that actually allows you to make money. How can we build trading strategies using Pandas? Well, we have, let me say, plenty of possibilities. We don't have, of course, time here to see all of those, but I'm going to give you a little tip in order to build a trading strategy with Pandas. One is by using the rolling function. And the rolling function is actually a pretty useful one, since it allows you to aggregate time series data with respect to a specific time window. In order to do that, let me create again a custom method that I'm gonna call, let me call SMA, simple moving average. And this return basically the application for each single row of your data frame, the rolling method, and in particular, I'm gonna specify the time window I'm interested in with the argument window. Let me say that this is fixed and is equal to 5, for instance. And then you want to get all the data in a specific time window of length 5, and then you compute the mean of those observations. What does it mean? It means that I start with an observation at time 0. If I try to compute the SMA for that particular row, I get obviously a none. For the second row, again, it's going to be a none, since I don't have a wider window to compute that particular mean. And as soon as I get to the 5th row, I have 5 different rows, and that 5 rows will be my time window in which I'm going to take a mean value. A natural question is, why should I use a simple moving average in trading? The answer is pretty simple. You tend to use a simple moving average since they are defined as actually trend indicators. And in particular, the simple moving average gives you the direction of the trend for your particular stock. I would say also gives you the strength of the stock in a particular time window. And therefore, you can build some strategies based on those values, and you can obviously position yourself on a stock either long or short, depending on the value of the simple moving average. So you can be very, as I said before, you can be very general and define this function in this way. I'm just leaving this for you because I believe it's going to be pretty useful if you are enjoying this webinar and you want to try by yourself some trading strategies. Try to apply this function by yourself with a time window which is flexible. And why I'm saying that? Because actually what I want to do is building let me say an Amazon data frame for the simple moving average. And I'm going to basically create this data frame by taking into account a simple moving average. And again, you can take simple moving average with respect to 5 days. And to do so, we are going to apply nothing more than the pivot close in position Amazon, since we are taking into account that particular column, and we apply the rolling with window equal to 5. And you take the mean. The reasoning is the same that I just described again. So I'm going to repeat for clarity. I'm going to take the first 5 observation in our data time series data. I'm going to aggregate them by taking the mean. And that is the observation for day 5, describing basically the previous 5 days in our time series. I'm taking the mean because actually you typically compute the mean, but you can use the median, obviously, since it's more robust estimator, but it's up to you. Typically, the mean is the one that you use. And for simplicity, I'm going to create another simple moving average at 10 and a simple moving average for Amazon with 20. And then finally, I'm going to assign the index as the pivot close index, just for simplicity. And the result is something like this. You have 3 columns for Amazon stock, the simple moving average at 5, simple moving average at 10, and simple moving average at 20. Well, you can understand now much better what those functions perform. As I said, the simple moving average at 5 is going to take into account a block of 5 rows, and for those 5 rows is going to take the mean value based on the observed values. So here you have 5 values, and you take into account the mean of the previous 4 rows, and the corresponding row, in our case, the fifth one. In the 6th row, you're going to take a window that is moving, right, but fixed, and therefore you're going to take into account from 2nd row to the 6th one, and you compute the mean, and so on and so forth. The most important thing is that the time window is fixed, but dynamically you are moving from the top to the bottom of your data frame. And the interesting fact is that here we have a simple moving average at 5, at 10, and 20. Not surprisingly, at 10 appears at the 10th row, and so on and so forth. Here it's wrong since, sorry, I missed the window of 20. And now it makes much sense. Okay, so as I said, simple moving average are very important because allows anyone to build a simple trading strategy. And in particular, suppose that you wish to invest your money on some stock, and in particular, you want to perform some short-term period strategy. And so the natural question that anyone asks before joining the stock market is, should I go long or short on that particular stock? It's a pretty important question, right? You want to make money, so you want to understand whether the stock is gonna increase in price or is gonna decrease the price. And so an interesting but very easy strategy is to use the price, the absolute price, with respect to the simple moving average at 5. In particular, you can say that this is pretty standard stuff, that if the price is greater than the simple moving average, you go long. If the price is smaller than the SMA, you go short, right? So typically, if you pay attention, you are building a trading strategy with just a simple application of Pandas function. So let's try to see whether this makes sense or not to us. So to check whether this makes sense, you can actually plot on the same graph the Amazon DF SMA at 5 and the closing price, the original closing price. So to do so, I import matplotlib.pyplot SPLT. I'm just using matplotlib because it gives me flexibility. It's, you know, as I said, matplotlib is actually the back end of the plot function from Pandas. So if you wish to apply the plot function efficiently in Python, you should learn at first matplotlib. This is my advice. But then it's up to you, because actually the plot function from Pandas is pretty useful and direct. So we are gonna plot the closing price for the Amazon stock, and let's use the fixed size again, the plot function from Pandas, and I'm gonna take the 10 and 8 again, and I'm going to take into account the Amazon DF underscore SME, and I'm going to take in particular the SME at 5, and I plot that function, that column, pardon. And then I'm going to add a legend and a PLT show. It's fine. It's not necessary, but it's fine. Here we go. So what's the bottom line of this plot? Well, as I said, we have built a simple moving average using the Pandas function window. And in particular, we are telling that if the price, which is the blue line, is greater than the simple moving average, typically it's a signal of the fact that we should be long. So the price of the stock is going to increase. Otherwise, when the orange line is actually greater than the price, the current price, we should go short. Another important aspect that I want to highlight is that it depends obviously on the time window you want to focus on. In our case, we are focusing on a very short period of time, namely a week, a trading week. But obviously, you can choose the SME you like based on your trading strategy. Here, I'm just focusing on a short term trading strategy. And therefore, if you pay attention, here in the first part of our plot, the price is pretty above the simple moving average. So basically, it's a good signal, right? Here, if you invest here and you go and you reach here to the top, you are making money, right? It's a good opportunity. But interestingly, you have a signal here. You have a big drop down on this SMI at 5, and not surprisingly, the stock has no power to get back to the original positive trend, because you see here you have a spike, but then it goes down again. So here is a good signal in this precise time that possibly you should exit. So here, when the blue line intersect below the orange one, it's an exit strategy, and that is confirmed by the data. because the stock went down. And therefore, the strategy is pretty simple. When the blue line cross above the orange one is a long strategy. When the blue one cross down below the orange, actually is a strategy, is a short strategy. Therefore, you should go short on that particular stock if you want to make money. So this basically concludes my exposure for those 4 functions related to time series data on Pandas. Now I'm here to answer to your question, if any. Okay, so there is a few questions from you. So can I pass the date column via the D type argument with read CSV? Yes, it's a very good point. You can. You specify in the dictionary the column date, and you say that you want that as a datetime. Typically, in my opinion, that is pretty cumbersome, since the datetime is actually is not a proper Python type. So my suggestion, and then going back to the code, is that in this section, you should specify the type of the columns that are native in Python, namely integer, object, and floats. If you want to parse more complex objects, such as the dates, you should always parse those with the parse dates. Not surprisingly, you have 2 different arguments to do that. But to answer to your question, you can do in the D type, but it's a little bit cumbersome. So my suggestion at the end is don't do that, but use the parse dates. Thank you. I saw now the suggestion you made clear. A comment from one of you said, well, you have SMA 20 should have a window of 20. Sorry for that. It was a typo, and then I figure out later. This is another interesting question, pretty challenging. He's asking me, this guy is asking me, can I get easily cumulative returns with Pandas? Well, the answer is not, I would say. The answer is not, because there is no clear function that does the job for you. But we can build it now in a few seconds, if you like. So let me say like this, getting cumulative returns in Pandas. This makes sense. This question makes a lot of sense to me, since at the end of the day, you as an investor, you want to understand whether you are making money, which is good, and we understood that particular case scenario. But if you just focus on a single day, possibly you are missing the whole story of your investment. What I mean is that suppose that you have invested in a particular stock 1 year ago. What we did was just focusing on a daily change, a simple return that is computed daily. But then you want to say, well, at the end of the year, did I make money? If not, how can I be sure about that? So to do so, you can actually compute. Let me say like this. I'm gonna call a method called cumulative returns that requires, again, cumulative returns, okay, that requires you basically to apply this algebraic expression Don't worry if you find it difficult. I'm just writing it because it's actually the way in which you should compute those. Comprod should be. So what does it mean? It means that for each single row, I'm going to take. So let me say like this. I have a data frame. I have a column. Let me say Amazon stock price, or let me say Amazon stock price and their corresponding daily change, the daily returns. For each single daily return, I'm going to pick the first row, and I make the cumulative sum. Then I have the second one, and therefore I'm going to take into account not just the single value observed in the second row, but also the previous one. And I iterate this procedure until the end of the data frame. And this is guaranteed with the function Comprod, which is actually taking the cumulative sum. The prod is misleading, but it's taking a cumulative sum of the single rows you observe in your data frame. Given that, you then take the simple returns and you apply using an anonymous function these cumulative returns. Okay, so here in this way, sorry, it's X, not row. Here in this way, you are taking into account cumulative daily returns. And in this way, you should be able to get a table that has a cumulative sum in terms of simple returns. So it's remember, was 4%, right? Remember that. Let me go back to the data. You add here 4% for the second change, right? So the first cumulative product is none. Then you have 4%. Obviously, you are the Comprod has the advantage of taking it with respect to a baseline, which is 100 basically. That's why you see 1. So you have 4%, 4 plus 5, 7. It's a cumulative sum, and therefore you get 6.1, and so on and so forth. So you get this for Amazon and Tesla. And once you get that, you can actually plot the result as we did before. Just a moment, because I am specifying the fixed size. And here we go. So you get a plot that is starting from 1, obviously, meaning that if you think about if at the end of the year you don't get any profit, you are actually break even. So you just have the same capital that you invested. But then that's why it's 1. But then you see from the original capital invested, you see that this is the cumulative gain that you are making with respect to the original price. And therefore, given the original price, the stock has increased pretty a lot. And therefore, if you add an investment at this stage, your gain would have been approximately 3.5 cumulative points, base points. And instead, the Amazon is pretty stable and therefore less volatile. And this should confirm also your analysis that you made before. Since if you remember, here the Tesla stock was much more erratic and volatile compared to Amazon. So this concludes for me the question that you ask. There is another one. Sorry. Is there other interesting function to know, like for time series? Yes, I would say yes. A good one that I strongly suggest is to range dates. Range dates, let me write here, range dates should be range dates. Let me check. Or date range. Let me check. Date range. Here we go. So this function is pretty useful, and actually you should use this function when you want to create a grid for your analysis based on some dates. So creating a grid in Python is pretty easy. Creating a grid made of date times is not as direct as creating a grid, a numeric grid. With Pandas, you can create a simple grid of date times using this pretty useful function. And this is really recommended from my personal experience. Another one, the rolling method. Let me say, it's not helping me. Anyway, the rolling method that we saw before was actually computed with respect to the simple moving average. You can, if you want to master Pandas with respect to the time series, you will be very interested to check the official documentation and see that the rolling allows you to specify not just a simple moving average, but different moving average function, such as the exponential one, but many others. So my suggestion is also to master the rolling, because we just cover a simple application of it. And therefore, my suggestion is also to check the rolling with more focus and more depth. Here, you see now, here we go. The help is helping me now. So it says, see also EWM, provide exponential weighted function, and expanding, provide expanding transformation. So those are the two natural consequences of the rolling function. So if you want to master it, check them out. Okay, I guess there is no other question. If you have any, it's the time. Otherwise, we can close the session.
Yes, we don't have any more questions at this time. So I guess we can conclude this session. That's it for today. Thank you, Andrea, for leading this session, and to our audience, we hope you enjoyed it. Before we part ways, just a couple of reminders. You will receive the recording of this session as soon as it is available. Please fill out the end of webinar survey, as your feedback is extremely helpful in understanding what kind of webinars you'd like to see more of, what you liked about this session, what you would like to see done differently. So please do fill it out. If you missed the previous episodes, again, you can find them on our website, specifically on cloudacademy.com/webinars. And episode number 5 of this webinar series, which will also be the last one in the Pandas Like a Boss series, will be taking place on May 6th. Don't miss out, and you'll find the sign up link in the follow-up email. So keep your eyes out for it. You will find both the recording as well as the link to register for the last session. Again, thank you for joining us, and until next time, goodbye.